Hi, welcome to a walkthrough of the OctaiPipe Federated Edge AI platform. I'm going to show you how to train and deploy a machine learning model on edge devices. The first step is to log in. Here you can see that I'm using Microsoft single sign-on. Other sign-on approaches are possible. Logging in takes me to the management interface where I can see devices and groups. From here you can access the documentation as well. This shows you all of the key features of OctaiPipe. The documentation shows how you can register and set up devices and create machine learning deployments. There's also an installing OctaiPipe section. This shows that you can now install directly from the Azure Marketplace. The device registration section of the documents shows how you can import a file defining devices. This provides you with a Docker Compose file that you then run on your devices to set them up. Once the device is set up, it appears in the OctaiPipe web management interface, showing that it's available, as you can see with these two devices. Now we can create groups of devices. I'm going to put these two devices into a group, showing that they're in our London office. You can use this approach to divide any devices into any kinds of groups that make sense, so you can easily organize many devices in many locations for deployments and federated learning sessions. You can see that I've added these two devices to the group and now they appear. The next section is going to make use of the experiments capability to deploy a federated learning workload. The developer interface is a familiar Jupyter Notebook environment where I can now see the devices that I was just looking at with the management front end, and I can define a federated learning workload with a few lines of Python. Here I am starting the workload. On the left you can see the configuration file that defines this workload. You can see that it refers to the two devices that we defined earlier. Then it shows where on those devices the input data for training the model is. And below this we see a section for where to find the evaluation data and another section showing which model to train. The model is defined in a model file, and you can see here that we're inheriting from a base PyTorch model. As you can see, the experiment's created an entry in the database, which we can now see is preparing. We can go into this and you can see the record which is stored in the database containing the YAML file, which says which devices were used, where the data was, and which model was used. As you can see, the model is now beginning to train on the right. During each step, the sharing from each device is sent back to the federated learning server, aggregated and shared back to the devices, so the error conditions reduce. Now we can see the version of the model that we've just created. It's version 34. You can see that this is shown in the interface on the left here with all of the other models, which can be grouped according to time or name or type. You can see version 34 is the one that we just created. So the next step is for us to deploy this version. You can see that the training workload has now finished, it's just cleaning up. And we're going to deploy the workload as a model for inference to predict the remaining useful life of an aero engine. This is defined in this deployment YAML file, which specifies the location. We're going to deploy it onto device 0. And we're going to enter the config file details here to say that we're now going to use version 34. Now I'm going to start the deployment. As you can see, a deployment has been created, which we can see in the management interface. You can see that it's running, and the information again from the YAML file is stored in the database. When we look at the devices, we can look into the details of the device that we've specified, and you can see that on this occasion the output of the inference is in a Grafana panel, which we're seeing here. Now we're going to end the deployment. We can see the entry here, and we paste it into this second cell, terminate the deployment. And we can now see in the management interface that deployment has gone from running to stopped.